I'm going to talk about 93 restored IP addresses. The question is a valid IP address consists of exactly 4 integers separated by single dots. Each integer is between 0 and 255 inclusive and cannot have leading zeros. For example, 0, 1, 2, like this one, and this one's a valid IP address. But for here, okay, you can be the single one, but if the current here is larger than the length is larger than the 1, you cannot lead the 0. And also this one should smaller than the 255. And yeah, it's not a valid IP address. Okay, so return all possible, give a string S contains only digits. Okay, this is only digits. Return all the possible valid IP address that can be formed by inserting docs into S. You are not allowed to reorder or remove any digits in S. You may return the valid IP address in any order. So like this way. So okay, so this you have to return all the valid. So definitely it's kind of like DFS, or yeah, I would backtrack recursive way to solve this problem. So the first is kind of like you have the start, and you have the part, because we only have the 4 parts to solve this problem. So for example, like 1, 0, 2, 3. So we first, it would be the start from the 0, and the part is 0. And then coming to the next level, and it should be the 1 pickup. It actually have the 3 branch for here, because we can pick up the 3 digits for the every part of this. So like for here we can choose this one, and for here we can choose the 101, and we come here, come to the burden, which means whether we find it kind of like a valid or not, right? 0, 1, 1, maybe 2, 3, maybe this is valid. If we come in here, we we create a new one here and then put in the result. So this is kind of like a backtrack solution here. So let's restart. Yeah, so yeah, this would be, use this one would be better. So we can take this example, like restore, right? So we call this is called like a backtracking. And this is initialized way, start from the 0, and the part is equal to 0, and the result is empty. So this is a string. So we start from here, and at the current here, we can generate like we can have the 3 options. One is we just pick up 1, and the second we kind of like pick up 2. The third way is 101. Then we go to the call that function and keep calling the backtractions, right, based on some conditions. Then finally we will find the results and add the global results, then return back, and then when the tree finish, it will return back the results. So let's be based on this information, we write the code here. Yep, this is and also I need the subresult and backtrack, and after the backtrack finish, we directly return the results. So this I need is the where the start and which part it is, and also for the string separate out. Yeah, this is what I need. So start from the 0. It should be no part, because if I start here, the point is at the here. As so when we stop, we need to stop at the part if equal to the 4, which means we already current here is already separate 4, but also we need to check current start whether is equal to the end length, because we need to satisfy all the numbers. We cannot left any numbers here. So if is, which means it's valid, then without add string join based on this one to join the subproducts. When all the finish, we return. Okay, so for this one, we also have to check the remaining. Is equal to the minor start. So for this one X example, and the size actually is equal to 6. So we have to check something here, like current start is 0, right? And the size, and if the current here, if the if the remaining it will encounter two things, too much or too less, too separate. So we can start from the two last one. So like if current here is the last, current here we have the part at the beginning, right? So the part is equal to 4. But current string is kind of like we just only have the we just only have the 2, if the 2 and 0, right? There's I can separate at this one and this one. It's I can handle the 2 part. So the results will be like this, but this one is not valid, so we cannot do this. We can just directly return for minus part or remaining larger than that, right? And also because the every word is just just the 3, right? If you have the number larger than the 3, this one is still not valid. So we also need to make sure the 4 minus part times the 3. This one, if equal this one, is okay, but if larger than that, it's not okay. So we can directly return. So this is kind of like a cut. Okay, now we keep going to the branch. Int len is start from the 0, equal 1. because I want to, at the first one, I want to pick up the length is 1 here, and the length should smaller and equal than 3. At the same times, the current start plus the length should smaller than the, like current here. If I want to pick up this one, it's okay. And the maximum I pick up is equal to the current start is 0, right? I can pick up 3. So it should be smaller. I can pick up 3 is here. Okay, length is 3, so 0 plus the 3 is here, right? But this one I cannot achieve, but I can equal to it. So it should be this one, and I plus plus. Okay, so now we have to decide cur string. It's what kind of like string. Cur is equal to the s char. Start is include, right? 1 and start plus the length. Like star plus the, star is 0 plus the 3. So it will become the 0, 3. 0 is include, 3 is not include. So we can pick up this one, 1, 0, 1. But we also need to check current value is smaller than the integer cur. If this value is larger than 255, we don't do anything, we just return. So this is condition. And also have another condition is the 0, 1, right? We cannot have the leading. So if the cur size, current is larger than the 1, at the same time, cur char at the first 0 is equal to 0. Return, which means not valid, return. Okay, so after these conditions finish, which means it's valid, now we go to the next level. So we have to add the subredout, like which means 1 here, okay, 0 here. And then we have to start plus 1, start plus the length, because we need to start from this one. And part, we add 1, so need plus string subredout. Oh, not this one, this is backtrack. Before backtrack, we need to add the subredout cur. Because this is a backtrack, so we need to subredout, so remove from the subredout size -1 and the return. Yeah, I can write the return or not. Let's see. Yep. And for the time complexity is we just only have the 3 branch, so the worst will be the O3. And space should be the how many level about this. The worst will be this one, so we can check 3 and yeah. Okay, so this is the code about this, and we can treat one example here, right? So we start from the 0, part 0, and because we're running at current level here, you can see here. We at the beginning start from here, and then we go in this one, coming here to call these functions, and we were going to check the part whatever these conditions, and it will based on this one, it has the 3 branch. It will prepare for the next. For example, we start from the first, right? And it will prepare all this one, or the substring is already added in the sub readout. Prepare everything now, and then it will calling for the next level here. And in the next level, it will do the same thing again. You do the same thing again. So we come here and we find this situation leading the 0. So we will not do that. We just return back, right? So, but this one is okay. So we will keep going here. And for here, we also start from the 1. So it will also call the backtrack, keep coming and keep going to the deep bottom here. We come in here, part 4. But when we come in here, the start not equal to length. So we just return back. Okay, so going to check the second branch. So it's not work, and keep return back, coming here. The first one is not work, so we go to the second one. Then it will go to this one. And this one, it will have the same thing. To call this one, and then go to the button, it's not work, so it will change another branch. Then come here, okay, this one is okay, so add the readout and return back and keep to find another branch. And when the tree finish all of them, we already collect all the readouts at the button, so we can get the readouts. Yeah, and thank you.